So someone gave you this expression where we had 3 plus 3 plus 3 plus 3, and they asked you to calculate the sum. It would be pretty straightforward. You could just say 3 plus 3, which is 6 plus 3, which is 9 plus 3, which of course is 12. But if you didn't want to keep writing out these 3's, you could just write out the expression in a much simpler way using multiplication. So that would give us 3, being the number that we're adding together, times 4, the number of 3's that we're using to get our sum. So our product would be 12, which is the same as our sum. But what if we had repeated multiplication? So here we had repeated addition and that turned into multiplication. But what if we had repeated multiplication? So we had 3 times 3 times 3 times 3. What form do you think we could use to write this out in a much simpler way, just like we used our multiplication here? Because of course, we could just calculate this. We could just say 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. But again, if I didn't want to keep writing out these 3's, what do you think I could use? Well, that's what we're going to be looking at in today's video. It's something called exponents. And exponents are values that indicate how many times we need to use a number when we multiply that number by itself. And of course, we use exponents so you don't have to keep writing out a number when we multiply that number by itself. So exponents are part of a power. And a power is a product of identical factors that consists of two parts. So if I write a power, let's say I have 3, and then I raise this to the 4. So in this power here, we have two parts. We have our 3, and this is the base. This is the number that we're going to be multiplying by itself. And then we have the 4, and this 4 is our exponent. And the 4 tells us how many times we need to use the 3 when we multiply the 3 by itself. So if we were to write this out in expanded form, we would get 3 times 3 times 3 times 3. And that gives us 81. And it's just like our expression here. So now we know that if we don't want to keep writing out a number when we multiply a number by itself, we can just use our exponents. So if I look at another power, let's say I have 5, and I square this, or raise this to the power of 2. And remember, it's not 5 times 2, but 5 squared. So if we were to write this out in expanded form, we would get 5 times 5. And that's because this exponent 2 tells us that we must use the 5 twice. And that gives us 25. So now that we've looked at positive integers as our bases, let's look at fractions as our bases. Let's say we had, I'm going to write here 1/5, and let's raise this to the power of 3, or cube this. So in this example, we have 1/5 times 1/5 times 1/5. So our product will therefore be 1 over 125. And that's because we write this out in expanded form like this because we have the 3 here, which is our exponent, and that tells us that we must use the 1/5 3 times in the multiplication. And that's why we end up getting 1 over 125 as our product. So now this is pretty straightforward, but what if we have a negative integer as our base? Let's say I have -2, and then I put this in brackets, and I square this. But then I write here -2 without brackets, and I use the same exponent, I square it. So there's actually a difference between these two. In our first one, in our first power, we have -2 as our base. So that gives us -2 times -2. Because we have our 2 as our exponent, so we must use this -2 twice in the multiplication. So that gives us 4. But in this example here, we have our +2 as our base. It's not -2 but +2. And that's because this negative sign here, it's not part of our base, but it tells us that we must multiply whatever our product of 2 squared is by -1. So our product, our first in expanded form, if you write our product, that's -1 times 2 times 2. So that gives us -4. Now, if it's easier for you to, uh, if you want to see this further, if you're having trouble with this -2, sorry, this negative sign here, it's basically the same thing as -1 times 2 times 2. And of course, we get -4. So you have to remember that with our first power, the -2 is our base, not the +2. And here, our 2 is the base, and we have to multiply whatever our product here is, 2 squared, by -1. Now this, as we see here, it's the negative sign times 2 times 2. And of course, if you're having trouble with this, you can just look at it as -1 times 2 times 2. So we've dealt with a few examples for our bases, but let's look at some examples for exponents. So in our first example, we're going to have 0 as our exponent. Let's say we have 3 and we raise this to the 0. So if we raise any base to 0, as long as it's not 0, we get 1 as our product. So this is going to be 1. I could even have -5, let's say, to the 0. And I'll still get 1. Now it might seem a bit weird to have something raised to the 0 and get 1, but there's actually a pattern in our products that leads to 1. So if we take this 3 here, 3 is our base, and let's say we start with 3 to the 3. We raise this to the power of 3. And that gives us 3 times 3 times 3. Because we have the 3 as our exponent, so we have to use the 3 times. So that's 3 times 3, which is 9, times 3, which is 27. So if we could also have 3, and then square this. So that gives us 3 times 3, and our product will be 9. And then if we have 3 to the 1, that gives us 3. So before we get to 3 to the 0, let's look at our products. So we have 27, 9, and 3. So as you can see, we're dividing by 3 each time. If I write this here, 27 divide by 9 equals 3. And then 9 divide by 3 equals 3. So then what about 3 to the 0? Well, it's basically 3 divided by 3, which equals 1. So if you write this out, 3 to the 0, that's basically going to give us 1. So to sum this all up, when we have 0 as our exponent, it's always going to be 1 as long as this base is not 0. And remember, even though this might sound a bit weird to have 1 as a product when we have 0 as exponent, it's because in our products we actually have a pattern, and we're dividing our products by whatever our base is. So here, our base it was 3, so we have to divide these products by 3 to get 1 for 3 to the 0. But let's say if we had 5 as our base, we'd be dividing these products by 5. So we and that's how we get 1 with 5 to 0. So in our final example, we are going to be looking at negative exponents now. Let's say I have 7 and I raise this to the negative 2, not positive 2 this time. So with negative exponents, what we're going to do now is we're going to take a reciprocal. So it's 1 over, and our 1 is our numerator, and our denominator will be 7. So whatever our base is, here it's 7, and we're raising this to the same exponent. This time it's going to be positive. So this will be positive 2. So it's 1 over 7 squared, which gives us 1 over 7 times 7. And that gives us 1 over 49. And if we look at our pattern again, we actually have our pattern with negative exponents. So if we take 7, if we start with 7 squared, we get 49, because 7 times 7, which equals 49. And then if we have 7 to the 1, we get 7. And then if we have 7 to the 0, like we just learned, it's always going to be 1. So that's our pattern with our positive exponents. Now if we move to our negative exponents, that's 7 to the negative 2. Sorry, 7 to the negative 1 first. So that's like saying 1 over 7 uh, to the 1, which is 1 over 7. And then 7 to the negative 2, which equals what we just had here, 1 over 7 squared, which is 1 over 7 times 7, which is 1 over 49. So as you can see here, our pattern still continues. Remember that with our pattern, we're dividing whatever our product is by our base. So our base is 7. So that's 49 divided by 7, which is 7. Divide by 7, which is 1. Divide by 7, which is 1 over 7. Now if we divide this by 7, so that's a 1 over 7. Divide by 7. That equals 1/7 times 1/7, which equals 1 over 7 squared. Now, if we remember, 1 over 7 squared is just like what our step was here. And that's going to give us 1 over 49. So I hope you enjoyed today's video about exponents. In our next video, we will be looking at more exponent examples, and we will be also moving on to power laws. So stay tuned for then. And if you have any questions, please leave them in the comment section below. Thank you.